All right, class. Today's the 20th. Today's the 20th. There we go. Make sure you have your packet and everything else you might need. Here we go. Page 5. Page 5. Okay. Here are those key features. They're the same exact key features that are on your cover. So make sure you have them labeled. Remember, this is a video. You can pause it and rewind it whenever you want. So if I'm going too fast, that's not an excuse. So talked about these already. The x-intercept. That's actually, we defined them down here. So here we go. X-intercepts. They're also called zeros and roots, just so you know. It's where the function crosses the x-axis, also where y equals 0. Okay, that's these points here. Right there, right there. It's where the function crosses the x-axis. Also, these points are points where y happens to equal 0. Like this one here is at, it looks like it might be like at 8, 0 or something like that. The y value is 0. This one over here looks like it's at like -4, 0 or something like that. But the y value is 0. The y-intercept, it's where the function crosses the y-axis. Okay, so this is the y-intercept here we're talking about, also where x equals 0. So you've known about the y-intercept for a while, like that's the y-intercept right there. Okay, it looks like it's at -5, oops, sorry, 0, -5, right? The x value is 0 for every y-intercept. We're going to use that information later. Axis of symmetry. Okay, the axis of symmetry, or line of symmetry, it's the vertical line where x equals some number. Okay, so it's an equation because it's a line. It goes through the vertex and divides the parabola in half. Makes sense because it's an axis of symmetry, not an axis of asymmetry. You know the difference? So axis of symmetry is, it's this dashed line right here. Okay, and it goes right through the vertex, as you can see. And it is x equals some number. Now this particular number looks like it's at, like the x value looks like it's 2, right? X equals 2, like that'd be that equation. The vertex. The vertex is where the function changes direction. Sorry, I think I mixed that up. It changes direction. Also the minimum or maximum. So what we got here, this is the vertex right here. It's at a minimum. Okay, some vertexes are at a maximum. Like if the parabola looks like this, that would be a maximum. Okay, the vertex is at this particular point. That looks like it's probably at 2, -6 or something like that. Okay, that's the vertex. Oh, and it changes a direction. Here's what that means. I'll use the highlighters here to show you. So at first, you know, we always read a graph from left to right, right? We always read a graph that way. So at first, it's just going down, right? Isn't it going down the whole time? Right until I get to this spot. And then it goes up. So there, we call it increasing there. Oop, that didn't work out how I wanted. Okay. All right, see how it's going up there? So that's the change in direction. Okay, domain here. The definition might sound kind of weird, but it's not really that hard. Is the set of inputs, that means the x value is the input, accepted by the function. I mean, they work for the function, aka all the x values, okay, that the function uses. For parabolas, the domain will always be all real numbers. In case you're wondering, what, how, why? It's the x values. Remember, this is the x-axis. You know that. You've known that for a long time, okay? So if you were to squish this parabola all like to the x-axis only, it would cover the entire x-axis, okay? Why? Well, simple. You see how it's curving like this? Well, it's always going out, and also it's always going up, okay? So it always goes to the outside, going to infinity on that side, and for here, going to -infinity. So it goes from -infinity to infinity. So that's why we say all real numbers, every number you could think of right now. And then the range. Okay, the range here, it's a set of all possible output or y values that can produce, determined by the allowed input x values, the domain, aka all the y values. Okay, just need to know that. We'll denote this by, well, I'll show you. Okay, I'll let this unfinished because I need to draw a couple things for you. So in this margin here, put two little coordinate planes like this, nothing crazy, okay, just two little coordinate planes. And I'm gonna have one looks like this, all right, and one looks like this, okay, something like that. Now, for the range, let's say this point, so that vertex, so this vertex here, let's say that is at 3, 5, okay? That's at 3, 5. Well, the range is all the y values that's used. So again, if we squished this line, this parabola, like just to the y axis, what y values does it use? Well, it uses 5, right? That's as high as it goes. Does it exist up here? No, it doesn't even exist up there. It's from 5 and everything below, all the way to negative infinity, right? So what we say is that y is less than or equal to 5, because everything below 5, less than 5. Makes sense, it's opening down, we say, so less than or equal to 5 makes perfect sense. And then over here, with the red one here, same basic thing. Let's say I've got this ordered pair. Let's say this is at 2, negative 4. Okay, that's where the vertex is. So the y values of this thing's used. Well, let's kind of imagine or draw a line right there. Does it exist here, like in terms of the y? No, it doesn't. No, it doesn't even exist there. It only exists from here and up to infinity, right? Well, where is this spot? This spot's at negative 4. So we say its y is greater than or equal to negative 4. Makes sense. It's pointing up. The parabola is pointing up from negative 4 upward. Okay. All right. Next page. Next page here. All right. We got this. Oh, you need to fill out this table. Okay. We're gonna look at the parent function f of x equals x squared. Okay. It's the most basic quadratic function called the parent function, by the way. Parent function. Okay, pretty common term that you'll use a lot more in Algebra 2 especially. All right, complete the table of values and plot the points. You know how to do this. F of negative 4 equals negative 4 squared, right? It says right there what to do. So you just fill this out. Just pause the video and fill it out. If you're someone who didn't fill this out, you just copied my notes, that doesn't help you. So maybe you should pause the video now and figure out how to get these numbers, okay? But remember, all these numbers are points. Like this is negative 4, 16. That's that point. So I'm gonna graph that point. Negative 4, 16 right there. Negative 3, 9 right there. Remember, 9 is between 10 and 8. Negative 2, 4. Negative 1, 1. 0, 0. 1, 0. 2, negative 4. 3, 9. And 4, 16. And you can see the dots make this curve. Like it says, we're going to connect the points with a smooth curve. There we go. Don't forget to put your arrows at the end. What shape is made by these points? That's called a parabola. Okay, the shape is called a parabola. The equation is a quadratic equation, but the shape on a graph is called a parabola. What's the lowest point on the graph? Well, that's pretty easy. It's right here. That thing is called the vertex. Okay, and it happens to be at, well, 0, 0 this time. Okay, it's not always at 0, 0. But for this one, it is. What's the domain of f? Meaning, what are all the x values that are used? Well, what did we say? Remember, this thing goes forever to negative infinity. It goes forever that way, by the way. Okay, it also goes forever up to positive infinity, for those wondering about that. Okay, sorry. And then goes forever to the right. So it goes forever to the left and forever to the right. Remember, that's how the x value goes. It goes left and right only. So it goes all the way to negative infinity and to positive infinity. So we just say all real numbers. All real numbers. What's the range? Now the range requires a bit more thought. The range of f is going to be only the y values. Remember, this is the y-axis. So does it even exist down here in terms of the y-axis? No, it doesn't. Okay, so it's none of those. It exists starting here at 0, isn't that the y value of 0? And it goes all the way up to infinity. So it goes from 0 to infinity. So it's just greater than 0. y is greater than or equal to 0, because it does equal 0. Also, you see how this is pointing up? That means it's going to be a greater than or equal to for the range. Okay. Where is f decreasing and then where is it increasing? If you read it from left to right, as you can see, it is decreasing this whole time, okay? And then increasing, I hate when it does that. Decreasing this whole time, right? And increasing this whole time. Well, how do we write that? What do we say instead of just looking at a picture, right? Well, what we have to do is realize we're talking about the x's. Okay? When is it increasing and decreasing? Well, for the decreasing, it's that highlighted green stuff, right? Isn't that everything less than 0? That's what we say. X is less than 0. Where is f increasing? X is greater than 0. It's just going to be the same numbers and everything, it's just the opposite sign. Also, I'm going to point this out to you now. Okay, I'll use this highlighter. You see this vertex, this 0 here? Okay, that 0, that x value, is the same x value as this right there. Okay, I know we got a lot of zeros being thrown around here. And this 0 with the vertex can tell us all this stuff. That's that 0 right there. They're the same thing. I'll show you that in other problems we do. Does f of x have a constant rate of change? No, it does not. No. Constant rate of change, by the way, is a line. Okay, like that's a line. We're not dealing with lines, we're dealing with parabolas. How can you tell? It's not a line. It's a curve. Okay, it's a curve. Here we use a dashed line to draw the line of symmetry. Okay, on the graph. So here we go. Line of symmetry is right here. X equals some number. Okay, that number is 0. We have seen this number many times before. It is, just so we know, this purple 0, the one I've been talking about right here. Okay, the same one that's here and here. Those are all the same zeros. Okay. All right. So what I'm saying is if that number was a 4, there'd be a 4 in all those spots. Okay. All right, here we go. Give two x values that have the same outputs. All right. Same output. Let's see what's going on here. What do you notice with location of these x values in relation to the line of symmetry? Okay, that's easy enough. That didn't show up good enough. These 2 points, right? They have the same, what does it say? Output, aka y values. Aren't they both at 9? Right? They're both at 9. What do we know about them? How far they are from the axis of symmetry? Well, they are. If we just measure this, just 3 boxes, right? 3 boxes. They're the same distance. Okay. So given 2 x values, we found them. They have the same output. Okay. What do you notice about the location of these x values? Same distance to the line or axis, same thing, of symmetry. Which makes perfect sense. It's a symmetrical shape, so you can find like its sister point over there. So that's exciting and fun. All right. All right, next one. One of the other teachers showed us this. We got space x. You see how it's the x-axis, right? Space y, that's the y-axis, right? But then space x squared equals y, y equals x squared is a lot of what we're doing. And it's a parabola. How about that? Pretty cool. Okay. And that's what we'll be, I'll change colors. And that's what we'll be kind of looking at sometimes, by the way, is if we shoot a rocket, what happens? Where does it go? That kind of thing. All right. What we got going on here? All right. Here's just some notes. Copy these things down. Make this sketch of this thing here and this thing here. You can see I leave some space. Okay. Put these words in the middle. Leave some space in between them because we're going to fill that out with stuff. Okay. So you're doing that. Okay. So you're making this. Pause the video to do it. And you should have paused the video, and here we go. Here's all this stuff, okay? The vertex here, I'll use my highlighter. The vertex here is this point right here. That's 2, 1. That's where it comes from, all right? The y-intercept, 0, -3, that's right there. You already know where the y-intercept is. You've known for a long time. The x-intercept, there's 2 of them, okay? That's this point and that point. The axis of symmetry is x equals -2. That's this dashed line, okay, that we have to draw in, okay? That's x equals -2. Okay, the domain, I told you, is all real numbers every single time. Okay, it's because this graph, it's curving, right? But it's always going out. It's always going out. It's always going out to -infinity on the left and to infinity on the right. So it's every possible number. The range, okay, its y is, well, let's look. Okay, isn't it from here and below is where it exists, right? So it's going to be less than or equal to 1. Now, that 1, okay, I'll do this here. It's this same, color works fine. So this 1 right there, it's the same as this 1 in the vertex. Those are the same numbers, not coincident. They're always going to be the same number no matter what, okay? Along those same lines, this one will work, this -2 in the vertex, that is this -2, but it's also these 2 -2s as well, okay? Where it increases when x is less than -2, okay? That's here, isn't this increasing until it gets to -2? It's increasing until it gets to -2, and then it decreases after that, greater than -2. So those are a lot of the same numbers you see. On the right-hand side with the red one, same basic idea. Okay, the vertex is right there. Okay, the y-intercept is right here, 0, 5. The x-intercepts, there's none because as you can see, it doesn't cross the x-axis at all. The axis of symmetry, that one here, we got to draw in. It's just a dashed line that goes vertical, straight through the vertex, right? It's x equals 2. And again, a reminder about this stuff. This 2, that's the x value of the vertex. Okay, that is the same number as that. They're always going to be the same because it has to run through the axis of symmetry, has to go through the vertex. Same with this number and this number, those 2's, they're the same thing. It's decreasing from x is less than 2, that's this here, and increasing there. The range, didn't get to yet. The range, as you can see, like it's nice and easy to make like a horizontal line right there where we need it. So make a horizontal line, probably helpful. And is it above or below that line? It's above, so greater than or equal to 1. Okay, and the domain is always all real numbers because again, it goes forever to the side. I know it's going up a lot. Okay, it's going up forever and it's going to the side forever every single time. Okay, so that's why it's all real numbers, everything. All right, this is your homework right there. Plus, you've got a concept check on Schoology. All right, get to work. Have a good day. Bye.